Assalamualaikum and good day everyone. My name is Shakirin and I'll be testing on the authentication mechanism for password quality, username enumeration, and password guessing. For password quality, whenever a user wants to use our shop, they need to register. So on the registration page, we have to insert these following credentials, which is the email that we want to register, the password, as well as the security question. So if we focus on the password advice, we can see that almost your shop advises us to use the following password. It contains at least one lower character, one upper character, one digit, one special character, and at least 8 characters. If we try to create a password based on this advice, it would be very secure to password guessing attacks such as brute force or dictionary attacks. However, OSG Shop does not enforce these rules whenever we try to create an account, meaning that regardless that if a user tries a password without following the advice, it can still be created. For example, in this case, we tried to use the password ABC123 and the account was successfully created. The second part is testing username enumeration. An attack is a technique that malicious actors use to discover valid usernames or accounts in the system. It's more towards to reconnaissance more than attack. If you can see here that if we try to use the forgot password features for an unregistered account such as ABC123 at your shop, you can see that the security question is grayed out and no question will come out. This means that it shows that the account is invalid. But whenever we try to insert an valid account like this, we can see that this is responded by showing that what kind of security questions that this user has used. So this is one of the flaws in the shop where the security question is the one form of authentication mechanism that is used to ensure that it is a valid user that tries to reset his password. But if an unauthorized user tries to do this, it can dramatically reduces the number of guesses that he needs to check to bypass this. The next part is password guessing. So referring to the previous one, which is password quality, we can try to brute force the user's password by using a brute force attack or dictionary attack by using through brute force intruder. So first we intercepted this traffic and proceed to generate a list of password that we need to use to brute force this. So we can see that since our shop does not enforces the password rules, we can easily guess the password using ABC123 by checking the responses on the burp suit.
Assalamualaikum to Dr. Faisal. My name is MEGAT FARIS bin FEDILEH and my Matric number is 074713. So now I'm going to talk about test any account recovery function. As we all know that account recovery function is the most vital to most systems nowadays, as they allow valid users to regain access to their account, such as Facebook, Instagram. All the social medias use this test account recovery function. So how does it work? So when we are trying to recover a forgotten password from an account, the system will immediately display the security question that user has chosen as an authentication mechanism, as we can refer in the figure 1.7, which is they have the company you first worked for as an adult. But it is also can be a double-edged sword for the user. Why is that? Because it's already immediately revealing the security question without any additional authentical mechanism, make it even more vulnerable to brute force and dictionary attacks, since it reduces the number of guesses needed to answer this question. So let's say like Instagram or Facebook, they also have their security question. But what makes it different from all web juice shop rather than other social media is, so other social media will display multiple security questions, and by doing that makes it more safer, uh, more safer rather than make it only one security question. Next, one of the flaw in all web juice shop is username are not obfuscated by default, which means that anyone can see what you publicly see, what you have posted. Let's say in this information you can see the banner at juice dash shop dash op and fry like it too. So what we have been posted publicly, everyone can see it. Okay. Now I'm going to go for the test remember me function. What is test remember me? Test remember me is a feature that saves a user login information so that they don't have to re-enter each time they visit the site. It's like a cookies for the site. These features works by storing the usernames and password in a cookie. As seen in the picture, you can see the ABC test at ju-sh-op and then the password. But what makes it vulnerable in this website? This is because in this example, the email address and the password are already entered when we visit the page again later, and this may result in data theft. An attacker, when access to the user device, can retrieve the safe login credential, especially if stored in plain text or weakly encrypted cookies. I think that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad JAILANI. The moment is 073206. Today I'm going to talk about test decision management mechanism. Okay, for test token predictability, it is important to ensure the system security. If the token are predictable, attackers can guess what valid token and gain unauthorized access to system or data. When we test it, we are going to use OS Juice Shop. We will test site token predictability using burp suit sequencer. We will obtain the session ID for this login session by capturing the login traffic. To capture token for analyzing predictability, we need to specify the token location in traffic. Once configured, we can begin to capture live tokens. A certain number of tokens are needed to ensure the validity of the test. This just show token randomness result. The overall result for randomness is estimated to be extremely poor. This means that the tokens are highly predictable and vulnerable to attackers. These are some of insecure transmission token. Okay. JWT tokens are encoded in base 64, but it is not encrypted. This means that anyone that intercept this token can decode and gain potentially sensitive information. The decode token reveals what information was stored and sent. We can see that the token is signed using the RS-256 login credential, the user roles, and account creation date. While certain information such as passwords are encrypted, it is still recommended to minimize the amount of information that is stored and sent in token, since any encrypted information can be decrypted if given enough time. Okay, these are example for the token. Okay. The example show that some part of the token are same and some part of the token are different for those two different accounts. It is to ensure authentication for each user. Okay, for the next part is test sessions termination. It is essential part of information system security assessment for the session termination technique by making sure that user sessions are swiftly and securely terminated when they are no longer required. This assessment reduces possible risks related to unauthorized access. It starts with a creation of a new account. A simulated scenario is executed to complete an assessment. The user checks in and navigates to the feedback section as seen in the first picture. Okay, this is just an example for the test session termination. Okay, the account URL is copied and distributed to another party during testing. After that, the account is intentionally logged out. Another browser accessing the URL is depicted in the second example. The outer column now says anonymous, indicating that this account, which executes the previous login procedure, can be recognized as such. This is where the change occurs. The account related token is set up for one usage and greatly improves session security by becoming invalid when the account is logged out. This thorough examination of session termination protocols protect against unauthorized access and show how robust the system security infrastructure is when it comes to token devaluation at the conclusion of a session.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amir AIZAT bin SAIFULAZAM. Number 072167. Now I am going to explain test for input-based vulnerability. We have two common input-based vulnerability here, which is SQL injection and cross-site security at SS. So SQL injection, it happened when an attacker use a web application to run malicious SQL command. This is caused by not properly checking the user input. So how it works? The attacker put SQL code into a form or URL, and the application run this code as part of an SQL query. So what the result will be? Data leakage, unauthorized access to data manipulation, education bypass, and system compromise. As you can see, this figure 3.1 and 3.2. Next, I will explain for cross-site injection. Cross-site scripting injection lets attacker inject harmful script into a web page, and the script run in user browsers when they visit the page. How it works? The attacker find a vulnerability input file and they enter a script like this, iframe, JavaScript alert, and so on. So what it can be happen? The attacker can steal in sensitivity data and changing the site behavior. So the website display this input without sanitizing it, causing the browser to execute the malicious code. As a result, the website will display the pop-up window of cross-site scripting. That's all from me. I will pass to the next presenter. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is LUQMAN AMALI bin ARMAN. My matric number is BTPL 22074825. So today I'm going to present to you about our penetration testing project, the suggestion of the to avoid the vulnerabilities. So the first attacks vulnerabilities that we have is the SQL injection. In order to prevent SQL injection, always use prepared statement or parameter queries to handle database input securely. Validate and sanitize all user input to block malicious SQL commands. Limits database user permission to minimum necessary for the application, and avoid exposing sensitive database error by using generic error message instead. So next one we have the cross-site scripting, which is XSS. So for XSS prevention, escape all user input before displaying them in web pages or scripts. Sanitize input to remove dangerous elements like script, tags, and unsafe attributes, and implement a constant content secure policy to restrict script execution to trust source and avoid directly reflecting unsanitized user input on the web page. Next is the general web security. We should strengthen our general web security by using secure cookies with HTTP only, secure and same-site attributes, enabling multi-factor authentication (MFA) for additional protection, limiting session duration and enforcing logout after inactivity, and avoiding the display of the sensitive system detail in error message, regularly updating software framework and library to patch known vulnerabilities nowadays, and also encrypting client server communication with HTTPS. So the last one is the secure input fields. To secure input fields like search bar, whitelist, only allow character and formats for all user input. Escape user input before displaying them to prevent XSS attacks, and limit maximum lengths of inputs to avoid excessive payloads or buffer overflow vulnerabilities. That's all from me.